Hey y'all, it's me, Miss B, and to start, let's go ahead and fill out yesterday's notes, how to find the vertical asymptotes, x-intercepts, y-intercepts, and horizontal asymptotes. I will not be going over this, so make sure you fill those out on your own. All right, so jumping into this first example, we already know how to find each of these things. So to find the x-intercepts, I'm going to set my numerator equal to 0. So I set 2x minus 6 equal to 0 and solve. So add 6 to both sides. 2x equals 6. Divide by 2, and x is equal to 3. So that is my x-intercept. And remember that that is a point. So I'm going to go ahead and plot the point where x is equal to 3 right there. All right, y-intercepts. What I'm going to do is I'm going to plug in 0 for each of these x's. So 2 times 0 minus 6 over 0 plus 2. So I get negative 6 over 2, which is equal to negative 3. So I go on my y-axis and plot negative 3. All right, vertical asymptotes. To find the vertical asymptote, I set the denominator equal to 0 and solve. Okay, this is a line, so I'm going to go ahead and plot that line with the highlighter where x is equal to negative 2. And then for horizontal asymptotes, I compare the numerator and the denominator, so I have x to the first over x to the first, so the numerator is equal to the denominator in degree. This has an invisible 1, so y is equal to 2 over 1, or y is equal to 2. So I'll plot the line y equals 2 on my graph. Okay, so then we can go ahead and graph this. It's going to go approach that, go through these 2 points, and then it'll be the opposite on the other side, like so. So there's the graph of that function. All right, this next one here. So again, to find the x-intercepts, I'm going to set the numerator equal to 0. So 3x equals 0. X equals 0. Plot that point. For the y-intercepts, I'm going to set each x equal to 0. So I have 3 times 0 over 0 squared minus 9. So I have 0 over negative 9, which is 0. So that's also 0. It's going to be the same point if it's at the origin. Vertical asymptotes, we'll set x squared minus 9 equal to 0. So we'll add 9 to both sides. So x squared equals 9. When I take the square root of both sides, I need to be careful and add plus or minus. So this is plus or minus, so x equals plus or minus 3. So I have 2 asymptotes, and we know because there's a 2 right there. So at negative 3 and at positive 3, maybe, I have vertical asymptotes. All right, then for horizontal asymptotes, I compare. The degree in the denominator is greater than the numerator. 2 is 1 is less than 2, so y is equal to 0 as an asymptote. So go ahead and graph that like so. Okay, and we don't really know what to sketch. There's not a lot to go off of. So what we're going to do is we're going to plot a few points. I'm going to pick a point for x and y. I'm going to actually put this down here so you guys know where to put it. So to sketch the curves, let's pick a few points. So let's do x is -4, x is 1, and x is 4. So we find our y values by plugging those in to our equation. So I have 3 times 4 divided by 4 squared minus 9. And you can plug that right into your calculator. You just have to remember all those parentheses. And we get 1.7. We plug a 1 in, 3 times 1 divided by 1 squared minus 9. We get negative 0.375, and then when we plug in a 4, or that should have been -4 before. It's okay. So this is actually for this one. Oops. And then we have 3 times -4 divided by -4 squared minus 9. We get -1.7. Okay, so we'll plot those points. -4, -1.7, 0, 1, -3.75, and then 4, 1.7. So our graph's gonna look like this. Just kind of shows us where it's supposed to go. So there's the left and the right. The middle's a little tricky, so because it's a little funny, what's gonna happen is it's gonna actually go through this point because it intersects there. So sometimes it will cross that horizontal asymptote, but very rarely.